So today we're going to be talking about multiple angle and product to some identities. So first of all, up here on the board, I have sine of 2 theta, and so we're eventually going to learn what a formula for the sine of 2 theta is. And so when I think about 2 theta, I think that if I add theta and theta, I'm going to get 2 theta, right? I mean, essentially that's what 2 theta is. It's theta plus theta. And so now what I'm going to do is I'm actually going to utilize one of my previous formulas, the one that I just learned, sine of alpha plus beta. Remember that from the other day? So the sine of alpha plus beta, remember, was the sine of the first angle, which in this case will be theta, times the cosine of the second angle, which in this same case is still theta, plus the cosine of the first angle, which is theta, times the sine of the second angle, which is theta. And so if I look at these, I actually have the same thing. I have sine times cosine and sine times cosine. I mean, they're the same thing, right? So really, I know if I add the two, that's just going to be 2 sine cosine. And so that's our first double angle formula. They call it multiple angle, but it's essentially just a double angle because when you take something times 2, you double it. And so if we look at the next slide, there's the first formula, and I just showed you how you can derive that. Now cosine here has 3 different formulas. And once again, I could derive them all the same way as I did on the first slide. We're not going to go through that in class just for sake of time. But these formulas, y'all need to get those down. Okay. And once again, I'm not going to require you to memorize these. I will let you have those on a note card come test time. And we'll talk about that because remember, your test is in fact going to be Thursday and Friday of this week. Okay. So, those 5 formulas. Okay, so let's go ahead and look at the next slide. It said find the values of sine of 2 theta, cosine of 2 theta, and tangent of 2 theta for the given value and the given interval. Okay, I'll be honest with you, for those of you that when we drew triangles, you understood those, this should be a piece of cake because all we're going to do is we're going to draw a triangle. Okay. And it's a pretty straightforward problem if you pay attention. The first thing you're going to focus on is this. What quadrant does that tell me that I'm in? What quadrant goes from pi to 3 pi over 2? What quadrant will go from pi, which is how many degrees, by the way? Pi is how many degrees? 180 to 3 pi over 2.
Oh, it's 3.
It's gonna. So this is going to be in the 3rd quadrant. So, oops, that's supposed to be an A there. Okay, so I'm going to go ahead and draw a triangle in the 3rd quadrant, because that's what it tells me it is. And in that triangle, they tell me that the sine is negative 7/25. So what sides does that tell me? Yeah, but like where? What side will be 7? And the hypotenuse is 25, very good. The opposite here is negative 7. So now I need to find what that horizontal side is. Does anybody remember what it will be since this is a Pythagorean triple? 24. And it's actually in this case going to be a negative 24 because of where it's located. Now if you don't remember that, you could use the Pythagorean theorem. Pythagorean theorem in that case would be 7 squared plus b squared equals 25 squared. And then when you do that, you would get 24. So now let's go back to our formula sheet. And our formula sheet said that sine of 2 theta equals 2 times the sine of theta times the cosine of theta. Correct? That's what it states? So now all I need to do is plug in those values. I already know from the problem that the sine is negative 7/25. From what I just found in this triangle, I know that the cosine is going to be, what? Negative 24/25. So all I need to do is calculate that, and that's my answer for the sine of 2 theta. So I need to take 2 times negative 7 times negative 24. And when I do that, what do I get? Three what?
36.
So I get 336 divided by 625. That's what 25 times 25 is. So that's what sine of 2 theta is. Okay? So far so good? Now I need to find the cosine of 2 theta. Now with the cosine of 2 theta, I actually have 3 options to use. I'm going to pick one of the 3. Can somebody guess which one and why? One minus 2 sine squared. That is the one I'm going to use. Can somebody guess why I'm going to use that one? Because there's sine given in the problem. Exactly right. Okay, because this is the thing. If you draw the triangle wrong and you mess up on the cosine of theta, you're going to get this cosine of 2 theta wrong no matter what. But sine of theta, I can't screw up just looking and saying, oh, sine is negative 7/25. So that's why I'm going to use that formula. So I get 1 minus 2 sine squared. So this is how I'm going to go ahead and write that. I'm going to go ahead and write it as such. So really right now I get 1 minus 2. 7 squared is 49. 25 squared is 625. So really it's 1 minus 98 over 625. So what is my answer going to be? What is 1 minus 98 over 625? Which is what is it? I want a fraction. Yep. $527 over 625. Okay. So that's what 1 minus 98 over 625 is. So last but not least, you need to find the tangent of 2 theta. There's 2 ways to find this. One, you can take sine divided by cosine. Okay, that's the first way. Or what you can do is use the formula. The formula is 2 tangent of theta over what? Squared. Okay. So 2 times the tangent of theta. Tangent of theta is 7/24 divided by 1 minus 7/24 squared. 2 times 7/24 is 7/12. Okay? So I really have 7/12 divided by 1 minus 49 over 576. Isn't that what 24 squared is? 576?
Yes.
Okay, so really you end up having 7/12 divided by, what is that, 527 over 576. What'd you get? $336 over 527. You should get 336 over 527. All right. Questions? That kind of ties together a lot of the stuff of what we've done the last few chapters, and so we're going to look at another one here. Okay. Now, generally, when you do these, you aren't going to have any of those crazy square roots. Okay, you're going to have numbers that are a little easier to deal with. So the first thing you're going to focus on is quadrant. What quadrant am I in? So I'm in quadrant 1. Very good. So I'm going to go ahead and draw. Oops. I'm going to go ahead and draw in a triangle. And in that triangle, cosine is 3/5. So what does that tell me? Yep, 3 over 5. So what's this? 4. So I start with sine of 2 theta. Okay, sine of 2 theta will equal 2 times sine times cosine. So 2 times, what's sine? 4/5. What's cosine? 3/5. So I have 2 times 4 times 3, which is what? So 24 over 25. There you go. Cosine of 2 theta. What formula should I use? I would do the 2 cosine squared theta minus 1. Reason being because the original problem had cosine. So even if you've screwed up the triangle, which we haven't, but we don't want to take a chance, I'm now going to take 2 times 3/5 quantity squared minus 1. So what is 3/5 squared? 9/25. So 2 times 9/25 is 18 over 25. Subtract 1. So what do you get? Negative 7/25. Yes, you can get a negative. And once again, there are 2 ways to do the tangent of 2 theta. If you're relatively certain that you've done the sine and cosine correct, you could actually just do sine of 2 theta divided by cosine of 2 theta. And that will be equivalent to that formula we had. Sine of 2 theta in this case is 24 over 25. Cosine of 2 theta is negative 7 over 25. So one of the beauties of these is that the denominators are the same. So when the denominators are the same, we can get rid of those. And we end up getting what for tangent of 2 theta? Negative 24 over 7. Remember, we don't put negatives in the bottom. Okay. Negatives will go on the top or even with the fraction mark.
When you do tangent like that, will the denominators always be the same?
Most of the times, yes. I would probably say 99% of the time they will be. Okay. So So now we're going to get to some solving equations. And so this ties into that quiz I just gave you back. And we've got a few of these problems, and then that'll be it for this whole section. Okay, now, for those of you, if you see like the beta, if you want to throw x in there, you can do that. It doesn't matter. I mean, it's whatever's easiest for you. The very first thing is you can't combine a double angle and a single angle. So your first task is going to be to get rid of the double angle. Okay? I'm going to say that again to make sure you understand. You cannot combine a double angle and a single angle. You can't do that. So you have to get rid of that 2 beta. So what I'm going to do is substitute in the only formula I have for sine of 2 beta. And that formula is 2 times the sine of beta times the cosine of beta. Okay. What do you notice about each of those terms? They each have a sine. So let's factor out a sine. So if I take out a sine of beta from the first one, what do I have? 2 cosine beta. Minus, if I take a sine from a sine, what does that leave me with? 1. Okay, make sure you don't put 0. So now we're going to apply our zero product property. Zero product property states that either sine of beta equals 0 or 2 cosine beta minus 1 equals 0. And now this is where your blue chart comes in handy again. Where does sine equal 0? 0 and pi. Okay? Well, you can put 2 pi too. Doesn't matter. Same thing. Okay, now we need to solve this one. So to solve this one, the very first thing I'm going to do is add 1 to both sides. And then now what am I going to do? Divide by 2. So using your blue sheets again, where does cosine equal 1/2? And there you go. That's it. Let's go ahead and look at another one.
What's this Thursday?
Okay, let's go ahead and look here. It says cosine of 2 theta, or 2 alpha equals negative sine squared alpha. So, remember, can't mix a double angle with a single angle. So somehow I need to change this. Now the only problem with cosine is that there are 3 different options you have. It's not like sine where there's only one choice.
Use the one with the sine.
Use the one with the sine. Now there are actually 2 of them with
Cosine
sine.
squared theta.
Okay.
Sine squared.
There's 2 of them with the sine. We're going to do the one that strictly just has the sine.
So 1 minus.
So 1 minus 2 sine squared. And the reason for that is I want to try, if I notice since I've only got sine, I'm going to keep everything in terms of sine. I'm not going to introduce another trig function. So now in doing this, I'm going to go ahead and combine my sines. So I'm going to go ahead and add my 2 sine squared theta, or sine squared alpha, sorry, to the right side. And on the left side I have 1. On the right side I have 3 sine squared alpha. Good.
Isn't it, you're in, there's a negative, the negative sign
Where, what do you mean negative sine squared?
original.
Oh, oops, sorry, you're right. Sorry, that was my screw. So it's just sine squared. Yes, good call. Sorry, I just missed that. So then now to solve that, how do you undo a square? Important thing, you gotta take the plus or minus. Some of you forgot that on your quiz. Can't forget that plus or minus. So really I'm looking for plus or minus 1 equals sine of alpha. Should have two values.
Pi over 2.
Pi over 2 and where else?
3 pi over 2.
There you go. Questions? We've got one more we're going to look at today. And there you go. Our ultimate goal is to rewrite this as a single angle formula. So once again, we have three choices. What one of the three do you think we're going to use?
Cosine squared minus sine squared.
Cosine squared minus sine squared. Why do you say that?
Because it has both cosine and
Because it has both cosine and sine.
sine.
That's right. And you're going to notice something here.
You can cancel.
Ah, what do you notice about your sine squareds?
You can cancel.
They're canceled. So this and this are gone. So really, I'm left with cosine squared minus cosine equals 0. And that was our whole goal, was to get it down to one trig function. How can I solve this? What? Now add a cosine. How about we factor out a cosine? And that leaves me with
Cosine and sine.
minus 1. So I have two quantities now according to the zero product property. Either cosine of alpha equals 0 or cosine of alpha minus 1 equals 0. So where does cosine equal 0, did you say? Pi over 2 and 3 pi over 2. That's my solution here. Okay. Over here, your solution is where cosine equals 1,
0 and 2 pi.
which is 0 and 2 pi. Questions? So today we've looked at the double angle formulas. Okay, that's all we're going to cover from this section is the double angles. We're not going to cover those other formulas that they give. This is what you can get started on. 1, 2 through 8, the evens, 9 through 11, 13, and 14.
This is 5.
Yes, it's 5, 5.